Good morning, afternoon, evening, everyone. I am Jacques West from Viasat Elevate team and will be your host for the next 30 minutes. And I lead our partner programs, Elevate and the Device Early Adopter Program. Thank you for joining us for this session of Elevator Pitches, a series designed to showcase the most innovative companies within our Elevate ecosystem. Today, we are excited to introduce AtomBeam, a cutting-edge technology partner that is transforming the way data is compressed and transmitted. We look forward to learning more about their revolutionary technology and how it can drive efficiency and innovation in various industries. Before we get started, a few quick housekeeping notes. The session is being recorded, so you can revisit it at a later stage. Please feel free to drop your questions in the Q&A box. Questions will be answered at the end of the presentation, and those we cannot get to, we'll do so after the event. As this is our first pitch session in this new series, please do give us feedback. So what is elevator pitches? They are designed to spotlight key partners within the Elevate ecosystem. Each session introduces a company at the forefront of innovation, sharing their expertise and real-world applications of their solutions. Our goal is to foster collaboration and explore how these solutions can help address industry challenges and, of course, unlock new opportunities. For those that don't know, what is Elevate? At Elevate, we focus on three core pillars that drive innovation, collaboration, and business growth for our partners. A growth program, helping organizations bring new innovation solutions to market. A community of like-minded peers who provide different and supporting capabilities that you can utilize, and an online marketplace where you can promote your own capabilities and solutions to an engaged audience. If you'd like to learn more about how to engage with the Elevate Partner Program, reach out to our team after the session or email us at elevate.partner@viasat.com. Today's featured certified Elevate partner, AtomBeam, specializes in advanced AI-driven data compaction technology, making data transition faster, more efficient, and more secure. Their unique approach to data compaction is transforming industries such as IoT, aerospace, defense, and cloud computing, enabling greater efficiency and cost savings. Without further ado, let me introduce our speakers for today. Our first speaker, David White, VP Business Development and Federal. We're honored to have Dave with us today. With over 30 years of experience, David has held senior executive roles, including SVP of Sales and CEO, where he has led organizations to drive exceptional growth and business transformation. His expertise spans multiple areas in the technology sector, making him a leading voice on how AtomBeam solutions can enhance operational efficiency and security in federal and enterprise markets. Following Dave, we'll hear from JC Lin, VP Sales Engineering, a seasoned executive with over 30 years of experience in product development, software management, and sales engineering across diverse industries. JC has a proven track record in data analytics, software-defined networking, telecommunications software, and oil and gas explorations. All areas where AtomBeam's technology has the potential to make a significant impact. He will take us deeper into the technical capabilities and real-world applications by providing a demo of AtomBeam's solutions. Now, let's get started. David, the floor is yours.
Go to the first slide, please. Hello, I'm Dave White. At AtomBeam, in essence, we turn narrowband into wideband, allowing customers to transmit 4 times more data over existing links. First, a little bit about AtomBeam. Next slide, please. AtomBeam is a startup. We're a startup in the San Francisco Bay Area. We have major partnerships, obviously, with Viasat, but also with Ericsson and their Cradlepoint routers and others. We've raised over 35 million. We have 56 currently, could be 57 today, full-time employees. We have contracts with the US DoD, and we've got a very strong patent portfolio. By the end of the year, we'll have over 200 patents. Today, we're going to talk about NURPAC. That's our release product. It is the product that increases your effective bandwidth and turns narrowband into wideband. We'll explain more about that in a minute. In development, we have a product called NURPAC Plus. NURPAC Plus allows users to encrypt at the same time that they're encoding data, and that gives you encryption with basically zero overhead. We won't talk about that today, but it's going to be in our future by the end of the year. And we also have a product called NURCOM that we're working with the University of Missouri, Kansas City to manage images. Right now, we're working with the US Air Force that will allow you to transmit twice the number of images over the same bandwidth. Next slide, please. NURPAC is lossless. Not one bit is ever lost. It's lossless. It allows for a 70 to 90% reduction of datagrams, and it's done very quickly in microseconds. That means you could save money in a use case, for example, from an oil field, an oil rig, out in an agriculture situation or utilities. So you could save money because if you're dealing over satellite, you would pay less. Or you can, as in the case of DoD and many other applications, particularly oil and gas, get 4 times more data now because it's done very effectively and it's also cyber strong. I'll explain that in a minute. How does it work? The system takes a look at messages. It looks at all the messages at the bit level. And it says, oh, I see patterns at the bit level. So I'm going to take those patterns and I'm going to assign a code word to those patterns. We're using machine language and advanced mathematics to do all of this, and it's done very quickly. In a matter of minutes, you've built a code book. And it finds those patterns on messages as small as 4 bytes. So we work on very small messages, something that compression can't do, and we build code books. How do we transmit? This is what happens in runtime. You will have a code book at the source. The source can be an edge device and typically is. In this case, you've got a picture there. It could be out at an oil rig and you've got an edge device, some type of ARM-enabled device. Could be our partner's Ericsson router. And then it transmits only code words. No data is ever transmitted. That's how we add security. Only the code words are sent, and they're sent to a code book at the other end, which is a customer destination. So the customer can decide where to send it. I'll show you how this works in the next slide in our SaaS product, but everything is done in microseconds. It's near real time. How do we deliver a service? NURPAC is a SaaS service. It's cloud-based today with AWS. You've got an edge network, as you see there at the bottom, with an encoder. It's a Docker container, very lightweight, residing on an edge device. Then the data, the compacted code words, are sent to an AWS cloud. The cloud does the training, creates the code books, decodes the data, and then sends it to the customer location. That could be in AWS. It could be in Azure Cloud. It's wherever the customer would like it. Everything is done in real time. There's full monitoring so that when you are looking, in the case that we showed there in oil and gas, and you want to take a look at what's going on and how are the pumps performing and what's happening, this is all done and visible to a user. This is an example of an actual customer application where the customer was sending 9 megabytes a minute. So even though these are small messages, there are a lot of small messages. And we were able to manage 9 megabytes a minute. And as you can see in the graph, the original data in blue, the compacted data in red, we reduced the amount of data sent over the network by an average of 70%, managing 13 gigabytes a day of data. What will NURPAC look like in the future? We will be encoding on edge devices, compacting. It will be encrypted automatically. Then it will be sent over Viasat satellite, where you're sending 75% less data or 4 times more data, depending on your application and need. It will then be encoded and arriving for cloud storage. And in the future, one thing that we didn't put on the earlier slide, it will be accessible and searchable. That's what AtomBeam looks like in the future. Let's see how it works today. Time for JC to give you a demo.
Thank you, Dave. This is Jesse. As we all know that a good technologies without ease of use interface will probably go nowhere. NURPAC Cloud implementation focuses on the two design goals. One is the ease of use, and the other is a seamless integration with the existing service. So these are the two main focus of today's demo, in addition to the real-time data compaction capabilities. So here's a scenario that I'd like to walk through. In the conventional IoT service, we have the edge device that collect and aggregate field measurements, such as the temperature, pressures, and whatever measurements they collect. And this information will then be processed and then send it to the SCADA server. The edge device is responsible for publishing this information to the SCADA brokers. And the SCADA server will then pick it up from there. So for the convenience, let's call this broker as the SCADA brokers. And when the SCADA servers receiving the data, then it will present it to the operator, and the operator then can make informed decisions in real time. So that's the IoT service today. As more and more IoT service requires the higher and higher resolution information in real time, the vast amount of the data has overloaded and congested the network. And this overloaded network issues will only get worse as time goes on. So the solution is NURPAC real-time data compaction can reduce the data size by 75% on average. That is, NURPAC compaction not only allows 4 times more data passing through the existing networks, but also greatly reduce the cost of the transmissions. The common question is, how difficult to integrate the NURPAC service with the existing service. And the answer is that the NURPAC compaction service can be seamlessly integrated with the existing service in a matter of a few minutes. In just a couple of deployment steps, it will allow the data compaction to flow through and continue the service. So those are the couple of steps. First, we will need to create the compaction service we call the connectors. And the connectors is the definition of all the associate components in this data compaction process. And once you create the connectors, the next step is to deploy the encoded containers on the edge device. Since the NeurPack implementation is in the cloud service, all the required components are already implemented and deployed in the cloud, ready for the service. The only moving part is the encoders that will need to be very close to the data source. And the encoder is implemented as a Docker containers with a very small footprint. And in general, it's taking like 20 megabytes of the memory space and a very little CPUs. It can be deployed in any edge device or routers that support the Docker containers. Once we complete these two steps, the NeurPack compaction service is ready for the data compactions. And the one last step is to move the traffic from feeding the SCADA brokers to the ingest brokers. And once the data goes to the ingest broker, encoder will then pick it up and compact the data, send it through the satellites or any other network transmissions. And it will deliver to the decoders, where the decoder will then decode the data and return to the original form, and also keep the same MQTT data structures, and then publish the data to the SCADA brokers, where the SCADA server will pick it up. So really from the SCADA server point of view, it doesn't really matter the data went through the compaction process or directly into the SCADA brokers. The SCADA server will then receive the data as is. And that's what we mean the seamless integration, no impact on the existing service. So in today's demonstrations, we are using the Ericsson's cradle point routers as an edge device, and the inductive automations, ignitions as a SCADA servers. So let's quickly walk through the process flow. The data comes in, and now it will go to the ingest brokers. Encoder will pick it up, compacting the data, send it through the satellites into the cloud, where the decoder will then decode the data and send it to the SCADA brokers. And then the SCADA server will then pick it up, just as if the data sent directly from the edge device. So the next step is I'd like to quickly run through the demonstration in real life. On the left-hand side here, this is the edge aggregator that aggregate the data from the measurements. And we're using the real IoT data in this case. And this data now is sent directly into the SCADA brokers, where the SCADA server pick up the data. So you can see the needle is moving and the number is also changing. That means the data is actually going through the from the edge device to the SCADA server. But if you look at the portals, there's no data going through. And that's because right now it's bypassed the data compactions. Now the next step is to deploy the process, to make it the deployments. A couple of things we need to do, as I mentioned earlier. First, we have to create the connectors. And creating the connectors actually is pretty straightforward. All the needed components already deployed in the cloud. The only thing is the encoders that need to be next to the data source. So what we really need to know is where is the data coming from? And in this case, it would be in just brokers that the encoder was subscribed to. And the next thing is where we're going to send the data to. And as discussed earlier, this will be the SCADA brokers where the SCADA server subscribed to. Once you fill in the details, now it will create the connectors. And by doing the connectors, it will also create a Docker profile. And this Docker compose file is to make it easy for the deployments. So once we have these connectors, the next step is go to the deployments of the encoder containers inside the net cloud. And inside the net cloud, it has the containers. You can create a project. And the deployment process is as simple as you copy paste the Docker compose file here. And once you save it and you make the commit, then the Docker, the cradle point routers will start to compose the containers and create the containers. And this normally will take a couple minutes to get it done. And once this is done, you can see the container will be in a running state. And all the connection from the Docker containers to the ingest brokers over the backend decoders, this connection will be automatically established without any human interface. So at this point, you know, the compaction service is ready to provide the service. Now, the last step is to cut the traffic from the SCADA brokers to ingest brokers. And what I'll illustrate here is this is the selections. Now I want to put it in the ingest brokers. And once I send the data to ingest brokers, now the encoders will pick up the data. And if you look at on the right side here, the SCADA server will continue the service, and you don't see the interruptions because the compaction will pick up the data and compact and send it to the SCADA brokers where the SCADA server was subscribed to. And so from the operator standpoint, they can see the difference. There's no gap in between. Now, let's look at the AtomBeam connectors. So here's the statistics. And earlier, I showed you there's no data. And now this is the first data point coming through. This statistics graph will present the minute by minute data traffics. And notice that the in this case, you know, this is the portion of the minute that has been reported. And there's the 5K of data going through, and it will reduce to 748 bytes, and the compaction ratio is 85%. And when we say the compaction ratio or saving ratio, 85% is every 100 bytes of the original data, it will become 15 bytes. So let's see now the second data point comes in. And you can see this is the second data point, and it's close to 100 kilobytes of data, and the compaction ratio is 84%. So it would be around the 84.5% on average in this particular case. So that's pretty much the demo. A couple of things I want to point out here. Here's a summary of the actual data going through 100 kilobytes of data and turn into the 15 kilobytes. and it's 84% compactions over data reductions. Based on the information, it will project how much per day, per week, and per month. And this can be used for your financial calculations and also planning. So let's just take a day as an example, 130 megabytes of data a day. That's the original traffic. And with the compactions, now it reduced to a 22 kilobytes and is roughly 84%. So one way we can look at this is it actually reduced 117 megabytes of data a day. So that's one way of looking at that. The other way to look at that is if we keep the same bandwidth of 140 megabytes a day and fully utilize that, we are looking at somewhere around the 600 megabytes over 650 megabytes of data can pass through the data. So you can squeeze a lot more data in here. So just want to quickly conclude the demonstrations. It takes a couple of steps of integration of NeRPAC compaction service with the existing IoT service. And in a matter of minutes, the NeRPAC compaction service can start the compactions and will be totally seamless from the existing service point of view. And the compaction ratio is close to 84%, meaning now we can have a five-fold of the data going through, or we reduce the data to the 1/5. So that's the end of the demos.
Great, thank you, JC. I think we have one more slide. If you would put that up, please. Effectively, what AtomBeam does, it allows you to deliver 4 times more bandwidth to your customers. Or if you are a customer, you can get 4 times more data now. You can go over Viasat networks. We've tested multiple times, so any Viasat network or any network, cell, satellite, it doesn't matter what the network is. Everything is done in microseconds, so it's done in real time. And it can work on any vertical. We are a horizontal platform, oil and gas, utilities, agriculture, our efforts with the US DoD, all of them work very effectively. If you want to contact us, we've got our contact there, atombeamtech.com. If you'd like a demo, you can contact our Director of Strategic Partnerships who works with Viasat, Ingrid. All of that information is there on the screen for you. And of course, you'll be able to get it afterwards when you review this demo and webinar again. Thank you very much for your time. Appreciate it. Over to you, Jock.
Thank you both. I think it was great to hear and gain a deeper understanding of AtomBeam's capabilities. Definitely appreciate it, I'm sure. I'm going to quickly just drop in some questions for you guys that came through the chat. One being, how is AtomBeam positioned to support growing demands in areas like IoT?
The more data that IoT is presenting to the marketplace is growing, as we all know, in zettabytes. We can allow a customer to manage that growth simply by reducing the amount of data that they need to send over the network. Or in the case particularly, and I'll use the US DoD, they want more data now. In the case of oil and gas, they want more data now. So if they're able to take new sensors and get more data because of IoT, they can now use that data in real time.
So I'd like to add a couple of points on that, and strategically, we partner with the key technology company like Viasat, Ericsson, and the inductive automation as examples. This creates ecosystems Our focus is the data efficiency, and this data efficiency will coexist with the IoT world, and that's the approach that we're taking to.
Do we have any other questions, Jack?
Yes, from Paul, we've got can NeoPack reduce power consumption on the edge device?
Can it reduce file consumption?
Power
I'm not sure that.
consumption. So can NeoPack reduce power consumption on the edge device? Is it one that we want to get back to?
Well, we don't reduce any of the traffic coming into an edge device. We reduce the amount of traffic going over a network. So we work on telemetry data and we reduce the amount of data going over the network. The amount of data going into the edge device will be the same. We cannot reduce that going into the device.
Thanks, Dave. I think, Paul R., if that does not answer your question, do feel free, to reach out and we can, or the team can dig into that. I've got one more from Jerry to JC. What does TTC stand for?
TTC is the telemetry tracking and control. And this is a terminology used widely in the DoD as well as the IoT world. And mainly just you have the telemetry data, you have the control data going back. So this is a real-time control with all the data comes in.
Okay, perfect. Taking that, we did run over a little bit. I'm going to squeeze in one more question. I think this is a good one. What is required at the edge in the context of an IoT application? Is this a hardware router enabled with NeoPack? Is there a chipset implementation? There's a bit of a mouthful.
No, that's all right, Jack. Thank you. It's a good question. The only thing that's required at the edge is an edge device. We are a small bit of software. We do not require specialized hardware. We do not make hardware. We have software. It's a SaaS service in the cloud. The edge simply has a Docker container, as JC had pointed out, about 20 megabytes of space required. There's absolutely no changes that are required to an edge device by any customer.
Excellent. Thanks a lot. With that, I want to thank everybody for joining. Just one or two things, and this is, as you can see, there is a email address, elevate.partner@viasat.com. Also remember to save the date. 27th of March is our next elevator pitch. Going to be very exciting. And then straight after this, please do give us your feedback. There will be a quick survey. And I'd like to thank everybody. Thank you very much.